Very good to be here. Hello, my name is Gustavo. I work at Sirius. We're a company that believes that providing your customers with a winning experience through innovation and best-in-class products requires a flexible, scalable, and future-proof architecture. What my team does, is we are responsible for creating the platform and the tools to enable your enterprise journey into embedded business. We are responsible for customer training and evangelism. What my team does is set the stage to help you to be successful and to feel awesome doing it. Thank you for being here. We have half an hour, and we're going to go over some of the ways that EDA can help your business innovate and grow an embedded ecosystem. Meet Sarah. She's a young professional with big dreams and a savvy approach to personal finance. On payday, while she's asleep, her salary is deposited into her e-wallet. A portion goes into savings and a portion is invested into an exchange-traded fund. Next morning, after 30 minutes of hot yoga, Sarah checks the stock market on her iPad and buys a stock a friend recommended last night using her e-wallet to pay for the trade. On her way to work, Sarah stops by Starbucks to get a nice vanilla latte. She pays for it by scanning a QR with her e-wallet. At lunch, she meets a large group of coworkers at a ramen shop. When the bill arrives, Sarah gets the bill and everyone chips in, putting money into her wallet with her e-wallets. After work, Sarah stops by the mall to get a new iPhone. Her current one is about 4 years old, and she wants a better one for the trip that she is taking to Taiwan soon. She gets a microloan from the retailer, which she can easily manage through her e-wallet. Finally, once home, Sarah spends a few minutes playing with her cat, Lucky, before reading the solar panel meter to check the energy collected during the day. She notices an excess was collected and decides to sell it back to the utility company for e-credit. So what are the trends that we see here? Consumers want cheap, convenient, and accessible finance, invisible, embedded into their daily lives. Sarah's story is a testament to the power of technology and financial literacy. What is financial inclusion? Financial inclusion is the availability and accessibility of financial services, such as bank accounts, loans, insurance, payment services, to people and businesses, regardless of their economic or social status. It is especially important because it opens financial services to people who have been traditionally excluded from the formal financial system. Low-income individuals, rural communities, women. Sarah's story shows why financial inclusion is so important. It's because it promotes economic growth. Sarah spends in retail, restaurants, reduces poverty. And also because it provides access to savings, investments, credits, insurance, etc. This makes it easier to perform financial transactions like payment services and mobile banking. Finally, it improves the overall welfare of individuals and communities because through financial inclusion, they can build assets, open saving accounts, start businesses, grow their businesses, pay for basic services like healthcare, education, housing, extra training. Sarah's story shows that financial inclusion is made possible because she has access to the right tools. Read embedded finance. What is embedded finance then? Embedded finance is the integration of financial services and products into non-financial platform and service companies. So what are financial services? As I said before, it's financial payments, lending, insurance, investing. In non-financial platforms, you see them everywhere. For example, you have e-commerce marketplaces like eBay, Alibaba, Amazon, Rakuten, Walmart. Ride-sharing applications like Grab, Uber, Didi, Careem, Ola. Other examples that you are familiar with are TikTok, Facebook, YouTube, Spotify, LinkedIn, Netflix, Airbnb, and the list goes on and on into retail, airline, automobile, supply chain, etc. The advantage of this is that customers get access to financial services and products without having to leave the platform they're currently using. And it also creates a more seamless and convenient user experience. Now, financial regulators, those government agencies and organizations responsible for overseeing and enforcing laws and regulations related to the financial industry, love financial inclusion. Some of these are like the European Central Bank, the ECB, in India, the Reserve Bank of India, in the US, the FINRA, the Financial Industry Regulatory Authority, in the UK. You have many, many, as you see some of these icons here. So all this, they have the goals of maintaining the stability of the financial system globally. They want to protect investors and ensure fair, transparent financial practices. Additionally, they set the direction and expectations for financial inclusion. Services that are fair and accessible to customers, an infrastructure that is up to standards and accessible to all providers, and finally, they also want to leverage the emerging technologies to make data-based enhancements to financial services. So we've talked about financial inclusion, we've talked about embedded finance. Now, the final thing is an embedded business. While embedded finance integrates financial services, embedded businesses integrate third-party business services and software into your own enterprise. For example, an HR platform called Zenefits embeds payroll, benefits administration, compliance, time and attendance tracking into platforms such as QuickBooks, Xero, and Slack. Salesforce is embedded into SAP and Oracle to provide enterprise resource planning. Asana provides software teams, organization, tracking, and managing of the work, can be embedded into Microsoft Teams, Slack, and Google Drive. What it means is that you can, if you have embedded Asana, the PM software, into Slack, you can use Slack to directly manage your project. If you have embedded Salesforce into SAP, you could use SAP to create enterprise resource planning without leaving SAP, right? And without SAP actually natively providing those functionalities, now it can take advantage of what Salesforce is doing. And the same happens with many others, like Twilio, which provides messaging among other things, is using Salesforce for the communications, and Zendesk and HubSpot. Stripe provides payments, is using Shopify and Squarespace and Salesforce. Google Maps, you sure have used an application like Grab or Uber or Airbnb or Zillow. These mapping applications are provided by Google Maps. So Google is embedded into these applications to provide, maps or traffic or directions. So what is the advantage then of embedding a business or embedded finance? Is that improves efficiency and productivity by letting your business focus on its core business and still taking advantage of your partners to provide all the other functionalities. So the key takeaways are that we leverage new technologies to drive innovation and financial inclusion, and that the most successful businesses build customer-centric experiences that provide a consistent view of the customer, that are personalized, delightful, and frictionless to the customer. So think about the past few years. New players like Amazon, Uber, Instagram, Netflix, Tesla, Spotify, WeWork, Regus, which is very similar, new technologies like IoT, blockchain, AI, ML, and many changes around the world, like social unrest. We have a lot of protests, riots, public health crisis, like the pandemic of 2019, recessions, inflations, fluctuation in exchange rates, economic sanctions, etc. So there is a lot of things happening in the world, and all this creates uncertainty. And the cherry on the top is that even the Earth itself adds to it with climate change. Despite all this uncertainty, businesses need to win customers, build partnerships, retain employees, and transform digitally. Oh, by the way, this needs to happen all the time and no matter what. Enter composable innovation. The concept of composable innovation is building new products, services, or solutions by combining composable blocks. Composable blocks are like Legos. What are the characteristics of Legos? I'm going to describe composable blocks, and you're going to picture Legos no matter what. So composable blocks are well-defined. They have clear interfaces and functionality, right? They are independent and loosely coupled. So you can have a bunch of Legos on a table, they're all independent, right? So they provide the flexibility and agility that you can combine them in different ways to create different solutions. They are standardized and interoperable. That means that you don't need to customize them to put them together. They are easily assembled, disassembled, reassembled, reconfigured to meet different needs and use cases. In other words, they are modular. They can be used and reused in different ways and can mix and match different components to create different solutions. So did I tell you that they look like Legos or not? So the advantage of composable components is that they provide you with greater flexibility, agility, and scalability to create different things, different products. At the same time, they reduce development costs because you can recombine the pieces that you already have working. And they allow you to have more rapid response to needs for innovation, to meet changing demands in the market and customer needs. So faster time to market. Composable innovation really empowers the digital enterprise. So let's recap. We want to embed financial services and other business software and services into an enterprise. To do this, we have identified that we need composable innovation. And to enable composable innovation, we need components that are independent and loosely coupled. The best way to connect all this, to connect, coordinate, and adapt the different components in a decoupled architecture is with events. Because events are the primary means of communication between different components. They can stay loosely coupled. They don't need to know about each other. They just need to know about the events, loosely coupled, right? And events can, on their own, stitch together multi-grain layers of decoupled services and orchestrate them via an event mesh. This is the definition of event-driven design. When Sarah woke up and browsed stock price information in real time, these prices reached her from the brokers via events. When she issued an order, that was an event. And that resulted in a trade, yet another event. Events are the fuel of the modern enterprise. Your components need real-time access to events happening anywhere in your business. All technology, like SOA, that architecture, may hold you back from listening and responding to events. The ability of your business to harness the power of events is key to its capacity to innovate, to adapt, to unlock the power, the business value, and to thrive. So, in order to do events, there are some architectural concepts and in architectural paradigms. MASA, Mesh Application Service Architecture, is one of them. MASA is a highly modular approach to building software applications using microservices, events, and service mesh. Everything that we have talked about, right? Components, microservices, events, and service mesh. Each service is designed to perform a specific business function and communicate with other services only through events, through a message broker or an event bus, if you will. MASA addresses the limitations of monolithic architectures and traditional SOA, service-oriented architectures, which can be inflexible and difficult to scale. Not because you cannot deploy multiple versions of your monolith, but because your team has to now work on a big thing and deploy the entire thing, as opposed to innovating little pieces. So some of the principles that make MASA successful are autonomy. It functions without Each service can function without dependencies on other services. Services are decentralized. That means that they operate without need for central coordination. As we've mentioned before, they are composable. They are event-driven, so they only communicate through events. They are resilient to handle failures and recover quickly. They are secure from external threats, and they should be scalable. That means that they can handle increases in load without impacting performance or availability. So if you follow all these principles, the benefits that you get with a MASA architecture is that, in general, the scalability and agility, that's the promise even of microservices, right? But let's zoom in and take a closer look. Because MASA allows microservices to be scaled independently, the user experience is consistent regardless of the device or platform used. Microservices in MASA can be reused across different experiences, saving time and resources when developing for multiple devices. MASA allows integrating new touch points and devices as they emerge, ensuring that the user experience remains consistent across the board. Some other concerns are security. Each microservice can have its own security protocols, more granular. You can have data protected in transit between microservices, and centralized and customized security management ensures consistency across all microservices. Monitoring, because microservices they distribute so many messages as you are going over, they can be monitored and analyzed individually. End-to-end visibility into the performance of a request as it passes through multiple microservices. You also want to have real-time log aggregation and analysis from multiple microservices to allow you to identify and address issues before they impact users. Traffic control. You get dynamic routing of traffic through service registration and discovery. This is super key and super awesome in MASA, right? Services really discover themselves because they register themselves, they discover themselves, which allows them also to load balance across multiple services based on traffic demands. And when everything else fails, the circuit breaker pattern prevents cascading failures when a service is really not available. Finally, MASA performs transformations to ensure that data can be understood by the receiving service. So no matter what technology or protocol or data structures a particular service is using, when it sends an event, that event goes through MASA, and MASA performs the transformation so that the receiving service gets it in the way that it knows how to interact with it. So services can interact with each other regardless of their underlying technology or data format. And finally, in the bottom, we have, the multi-grain, all the different services. MASA enables the importance and emphasizes the importance of decentralized network of services of various granularities. And we can see this in many, many ways. Right? Services can be discovered, connected, and communicate with each other in a flexible manner. So services can be of any size. They can be macro services for an entire business capability, microservices for smaller functionalities of a microservices, or mini services if they are just like smaller functionalities of a microservices. Services can be new or they can be legacy. Right? So they can, because they communicate through APIs, it really doesn't matter, right? So what the type of the service is, as long as it's using APIs and events. So this has a corollary, another advantage, because it also enables the gradual system updates to upgrade your system from an old legacy into a more modern system without the complexity and the risk of a complete overhaul in one go. MASA also supports different, deployment and management of different clouds, whether it's on-premise or cloud-based. So cloud-based services, when scalability is necessary, you may choose them, or you may choose on-premise services when tighter control over sensitive data is key. The choice is yours. Depends on the business type or your sensitivity of the data, and compliance requirements, etc. Finally, you have two other things, purchase and homegrown. It doesn't matter, because as long as the services follow MASA principles, they will communicate to each other via events. And MASA can be implemented using both self-managed or third-party, so you could have self-managed services, which requires a little more resources and expertise on the side of your business, or third-party, but this may come to the cost of losing some customization or control. We've seen how loosely coupled components glue together with events, and this is the key to agility and efficiency. I'd like to mention two aspects that we've discussed in passing, but are worth highlighting. Successful composable innovation requires event streaming and event management. What is event streaming? Event streaming is really, all the events that are happening, that's the event mesh, right? That's the internet of events for your enterprise. What it means in simple words is like events can be produced anywhere in the enterprise, and events can be consumed anywhere in the enterprise. So consumption and production can happen anywhere on your enterprise. Now, for event management, what you want to be able is to define, manage, search, recombine, and govern all the events in your event mesh, as well as easily build and integrate applications. So event streaming and event management. So this, especially event streams, are now pervasive in all sorts of industries like automobile, airline, retail, healthcare, banking, manufacturing, supply chains, in new business models as they appear. For all this, EDA is imperative. EDA is imperative to build a composable solution, but a composable solution that works well. What makes a composable solution work well? So it has to be responsive. Constantly monitoring the events to anticipate and respond to changes or potential issues before they occur. The system remains and must remain stable and functional even in the face of unexpected events. It has to be extensible. That means reusing systems and tools already in place. Because components are loosely coupled, it's easy to add and remove different functionality. This saves you time, saves you resources, ensures compatibility, and you can change quickly with minimum risk of errors or technical issues. Services can be plugged in without disrupting existing architecture or having to overhaul the entire system, giving you freedom to innovate. So additionally, EDA can help reduce the complexity, speeding up development cycles and improving overall agility of your teams. It has to be integrative. That means that because all components are decoupled, data exchange happens exclusively via events, then the old and the new can live together. Homegrown or third party can live together, as we just discussed. Right? So without having to know the specifics of each other in implementation, because technologies, technical specification, protocol, data structures, business logic, they do not matter. What matters are the events. And finally, they have to be scalable. Scalable means that in a traditional tightly coupled system or an SOA architecture or a more monolithic implementation, when one component needs to communicate with another, typically it has to know the location and the implementation details of that component. This makes it difficult to scale the system because adding or removing components can cause a ripple effect that affects the entire system. EDA allows for elastic scalability via event-driven scaling. Components can be scaled independently based on the number of events they receive or generate, and they can handle increased workloads and business growth without disrupting the system's performance or availability, any downtime. So really, EDA is your guide for agility, resilience, operational efficiency, facing disruption, and moving your business forward. But EDA on its own actually has some problems now, right? So now we have some technical challenges that come with all these wonderful things that EDA gives you, right? And you should know this was coming because if you work with services of any kind and events, you know that they come at the cost of complexity. So let's talk about some of the issues. So data consistency. How do we achieve data consistency when you have distributed databases and services all over the place? So we sacrifice then consistency, immediate consistency, by applying the CAP theorem. Let's talk about the CAP theorem very quickly. CAP theorem says that it is impossible for a distributed data system to simultaneously provide all three of the following: consistency, availability, and partition tolerance. In the asset, and when you only have one database in a single location, you can apply asset properties, right? Atomicity, consistency, isolation, and durability. So in that case, we are really emphasizing the traditional thing, which is the consistency. But in base, as opposed to asset, for distributed systems, then we sacrifice strict immediate consistency for availability and partition tolerance. Obviously, we're going to have eventual consistency. That's the goal. But that's the main principle, right? So we have to go, it's basically available. It has a soft state. Whenever you get it, you will get the state, but it may not be the right state at that point, and also eventual consistency, right? And so that's the compromise. Finally, you should be using the TCC model, right? The try, confirm, cancel, which is this transaction model to ensure the data consistency across multiple systems, can actually work, right? So in the try phase, you try the transaction until, you wait for the confirm. And if the confirm is received, then that transaction has been completed successfully. Otherwise, if you're in the cancel phase, then you cannot complete it successfully and release it and revert the changes. This handles situations where the services are involved in a single transaction, such as when updating, data across multiple systems. This is the data distributed. So the next thing is, how do we support stateful processes when we are, working with events, really, and over anywhere on the globe and with multiple databases? So they are easy using synchronous models, right? But they're a lot more difficult, so synchronous models like RPC or RESTful. But when you're using EDA, it becomes a lot harder. In this case, what you need is some kind of tool, perhaps, right, to allow you to transform asynchronous into synchronous. And creating this tool is not necessarily an easy task, but it is, especially to coordinate all that. But it is definitely something that you will need to solve this stateful support. Next, for workload, unpredictable workloads, right? So a payment service needs to handle traffic from partner retail services, so you don't know how much it is that you're going to be handling. In a distributed architecture, you don't know. So some of the things that you do are like, service downgrade or circuit breaker. So some of the other mechanisms, auto scaling, right? So caching, rate limiting, asynchronous communication, allows you to reduce the risks of service overload. You can reroute things into different services. Circuit breaker, as we mentioned before, and service downgrade. And so refers to, how you can lower the quality of a particular service so that you can actually still be available. The next thing would be how we handle message security. So the event mesh is really the one in charge of encrypting and decrypting the messages when publishing or subscribing. So no longer then the business logic has to worry about this communication security. And so it's neither in the business logic, it's not in the application logic. Now it's handled by the event mesh. Next, for monitoring, using the application performance monitor, the APM, with unique transaction IDs in all the events in one transaction flow allows you to chase a particular transaction through different clouds. So, but for this, you also want to have a unified log center and monitoring, to support monitoring not only across one cloud, but across no cloud, private cloud, public cloud. And you can have a consolidated view end-to-end of a transaction. And finally, how do we integrate systems with different technologies? Well, as we already said, since MASA is based on events and all these different components connected through events are really loosely coupled, then it really doesn't matter, right? So MASA ensures that you have this. No problems with integrating all sorts of different systems and architectures. And this is also what Gartner has called the hybrid integration platform, which integrates various systems, applications, data sources, all this through, data exchange that happens through events. So some examples of these are, for example, the Boomi, IBM App Connect, Microsoft Azure, Logic Apps, et cetera, et cetera. So let's take a look now at a loyalty platform example of financial embedded finance. So this is an application where a customer can make payments, and every time they make payments, they earn points in real time. And the bank then sells these points to their ecosystem partners and customers. How is this enabled through EDA with EDA? Is because when a bank needs to make this, it needs to integrate with different business partners. So one, you have financial embedded finances, and also, which is the embedded finance part that we discussed before, but you also have embedded business because you have a bank that is actually working with different partners, different businesses that are providing these different services. So, and they may have different technologies, they may have different clouds where they live, right? And so all this flexibility that you need to communicate with your different partners in different technology stacks, in different clouds, it's very, very easy when you're using EDA models. So also you need to be able to multi-cloud deployment, to have multi-cloud deployment. And this is also part, it doesn't matter from the EDA perspective, right? Whatever it is, it's working because of the EDA. So if we zoom out a little bit, we can also see what a collaborative ecosystem would do. So not only now that you have a payment part, which would be, or a loyalty, which is one of these hubs in here, but you would have all sorts of different hubs that provide you with different service provider services, be they loyalty, maybe they are HR services, maybe they are payment, maybe they are loan applications, maybe they are insurance, whatever it is. If your business application on the very top can connect to the event mesh through whatever service, whatever protocol, could it be for mobile, could it be for a browser web, could it be a REST API, it doesn't matter really, right? As long as it connects to the mesh, then it has access to all the different services that the partners define. And this is the advantage of using the EDA in your design and in your architecture. Well, thank you very much. This is all that I had to present for you guys, and I hope it's been useful.